There we go.
Cool, because we've got a couple
Start
of
off.
so I haven't come back to the quarantine. Okay, quick reminder on matrices. Let's define actually break define. C can be 5, 6. That's 5, 6, not 56. D can be 7. Oh, 7, 8, not 7, 8. Cool. E can be 1, 2, 3, 4. F can be 1, 2, 3, 4, 5, 6. F, G. 6. Okay. Cool, bunch of matrices. I want to know, can I add A and B?
Yes.
Yes, okay. Can I add B and C?
No. Yes. B, C.
No, okay. Can I add C and D?
Yes.
Okay, so what's the deal?
It's different orientation.
Right, orientation matters, right? Whenever you're adding and minusing, they have to be the exact same kind of matrix. Okay? 2, by the way, this counts as 2 by 1. You measure down and then across. Cool, so that's 2 by 1. Do that in a different colour, just so that makes sense. Alright, 1. Cool, whereas these guys are 1 by 2. Cool, so add minus works exactly as you expect. Everything just has to perfectly line up. Cool. Can I add any combination of E, F, G?
No.
No, right? Can't add or minus any of them. Can I multiply E and F?
Yes. Yeah.
Can I multiply E and G?
Yes.
Oh no. Can I multiply F and G?
Yes.
Okay. How do you know if you can multiply matrices? Okay, so one way is to draw it. That's the slower way, but we'll do it. So we'll go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. Right, if I multiply E and F, I'll get a 2 by 3 matrix. Right, because I can put the first thing goes on the bottom left, the second thing goes on the top. Right, if it makes a rectangle as a result, it's fine. Alright, what was the next one I said? E and G. There we go. Cool. Does that work? No. Okay. In fact, the way that I've described that. That's really dumb. Alright. So I'll just give you the proper definition for it then. Oh, there it is. This is 2 by 2, 2 by 3, 3 by 2. Okay. E by F would give me 2 by 2 by 2 by 3. E, G, F, G. E is 2 by 2 multiplied by G, 3 by 2. F, 2 by 3, G, 3 by 2. Okay. If the things next to each other are equal, then you will get a result. The result will be whatever the other two are. These ones don't equal, therefore does not exist. These two do equal, therefore my result will be 2 by 2. Okay. Next thing. True or false? These are matrices.
False.
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 False. Okay. So the way that we can say that that's definitely true straight away in this particular case. The way that we can say that this statement is false, given these examples, is we'd have a 2 by 3 multiplied by a 2 by 2. The 3 and the 2 would be next to each other, so it doesn't even exist, much less be equal to the other one. Cool. So that's the only thing in matrices that is a very common error. It's going, oh, A times B must be the same as B times A, but it's not in matrix. You just have to be a little bit careful about it. The other thing, let's actually do, we'll do F by G. Okay. F times G, we'll actually run this whole thing out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Do we remember how to actually get the result of this?
Yeah.
One yes. The rest of us are looking a lot more quiet. Okay. We should end up with 2 by 2. Okay. There's a whole bunch of different ways to do this. There's a whole lot of really complicated ways, and I think the way that I'm going to, or the way that I have taught you and the way that I'll do it again, is the simplest way of thinking about it. You write them both so that the first one's on the bottom left, the second one's on the right. That point is the one that I want to figure out, the top left. Go as far away from that as you can, and then start multiplying. 1 times 1, 1. 2 by 3, 6. So plus 6. Come in. 3 by 5, 15. Now I've entered the thing at the same time. So I know I'm good, that one's done. Cool. Next position, as far away as you can. Cool. 1 by 2, 2. 2 by 4, 8. 6 by 3, 18. Cool. Come inside, they're done. Next one. As far away as you can. 4, 15, 30. Inside, done. Last one, far away as you can. 2 by 4, 8. 4 by 5, 20. 6 by 6, 36. And then just knead it up to be whatever those results are. 22, 28 is 49, 49? Yeah, 49. 50, 64. Cool. That's all familiar? Yeah? Okay, because you're going to be doing a bit of that multiplication in a second. Cool. Yeah, getting lots of answers. That's good. Alright. I need to get to all that. Alright. Go. Alright. So ultimately we're going to use this stuff on these. I'm going to start with something simple that hopefully you should be able to solve very quickly. Right? Guess what you're going to do? Solve that very quickly. Ready, set, go. Just the normal way. Or whatever your normal way is.
X 2 4 이거 R6 내가 막
Yeah, we got that.
Yeah, that was only for the first two, isn't it?
Yeah, just for this, just this.
Oh, yeah.
Not this, no, I don't want you to touch that.
Okay,
Just
that's
this.
done, yes.
Yes, go, we're all happy?
Yes.
Yes? Go, what do we get?
1, 2.
X is... What?
Oops. Well, that tells us something went wrong with the kin sure.
Well, I got 2 and 1. Yeah, I got
1, 2.
Right, 2 and 1 or 1 and 2?
Like X equals X equals 2 and 1 is
X2, Y1.
Yes, right. So the point 2, 1.
Yes, yes.
Satisfied, okay, cool. What happened here?
其实这个不用算，猜都能猜出来上面算就行，对啊。上面乘2，然后减下来就完
Oh,
了，
that's a 4.
直接对。
Okay, right.
这得就算就行。
How have you done this?
有些时候我这是算的时候根本不会有
That's
这过程这一
There you go, you
怎么
just
办？
transcript error. Okay.
总之就是知道。
No, he wrote a 5 for that, and then on the next line he wrote a 5 for this as well. So it just stuffed it. Right.
加几个吧。
No, that's what first thing you always do is transfer, then check that you've transferred everything correctly, then calculate. Yeah, transfer error stuff. Anyway, cool. So hopefully we get, what do we get? 2, 1?
Yeah. Yeah.
2, 1. Cool, everyone's happy that's all, that's boring? Yep, good.
Yeah.
Alright, we're going to do this the matrix way. Now, I'm quite sure that you'll be like, why the hell would you do that? It's because of this. And also because of the potential that this has later on. But for now, this will look ridiculously long because that took you guys a couple of seconds, hopefully. No more than a minute anyway. Okay, first thing we're going to do is turn it into a matrix equation. The way we're going to do that. Your coefficients of these row numerals. 1, 2, 2, 3. The variables are y and x in this case, and my outputs are 5 and 8. Now, if these were in a different order, then you have to manipulate a bit, but I'll put everything in the same order, even in the next one I'll put it in the same order. 9 times out of 10 they'll be in the same order, but then sometimes on the multiple choice they'll be annoying and they'll flip and then they'll give you an answer as though you hadn't flipped, just to trap people. So just make sure that all your x's, all your y's, doesn't matter which way around, just so long as they're all in line, and then you write them in whichever order they came in. Cool, okay. So I've got this. Yes, cool. Notice that if I try to expand this, I'll get 1 times y plus 2 times x, 2 times y plus 3 times x. So it's the exact same thing. Cool. Now we want to do some matrix algebra. We're going to call this A, we're going to call that x, we're going to call that b. So we've got A times x equals b. Cool. Alright. I want to solve for x, the x matrix. Alright. Intuitively, what would you like to be able to do? Right, you'd like to divide by A. Right? Does that exist in matrix? No. What do you do instead? Right, have to multiply by that inverse. So, multiply by an inverse. Technically this goes on that side, but it doesn't really matter since it's only 12. Well, it does matter because you automate, but anyway. Now, we're going to cheat a little bit with the matrix algebra and just say, okay, this thing has to equal that. Put it the right way around, haven't I? Go right to left. Yes. Cool. Great. Alright, so now all we need is that inverse matrix. Alright. Do we remember how to get the inverse of a matrix?
1 over A.
Say again. There you go, 1 over AD minus BC. That's the coefficient, then you need the matrix bit.
D minus.
And then you make the second and third negative.
Hey, very good. Oops, that's me. Cool. So for a 2 by 2, that'll work. Easiest, and I don't think this is on your formula sheet, so you have to remember this. But yeah, easy way to remember it. AD are the years that are positive, BC are the years that are negative. Easiest way I find to remember it. Remembering this, you know that everything changes in one way, right? AD are positive, so they must flip. BC are just negatives. Cool. So how you remember it, totally up to you. That's the way that I remember it. Or you can just write it 60 million times and then your hand will just take care of it for you. Whichever you prefer. Okay. So, for us, get that out of orange, we'll do it in green. Cool, 1 over AD minus BC, bracket D, negative B, negative C, A. Cool, C, let's get to go. Everyone happy with the substitutions? Yes. Cool. Alright, now we're just in calculate mode. What do we get? The -1. Oh, yeah. 1 over -1.
Isn't that just the same as -1?
Yeah. Cool. That's the same as just -1. So we end up with a matrix of -3, 2, 2, -1. Happy days? Yeah, cool. We've got to use that. So we've got X. Actually, blue, because that's not the general case anymore. That's specific to this. That is like cool, multiply these through. Multiply everyone. -15 and 16 gives me 1. Actually, maybe I should write this down just to make it clear. So this by this, this by this. So right, -15, positive 671, and sorry, 10 meters. Cool, so we got 1, 2. Keep in mind we had y first, so and therefore our point is actually 2, 1. Because we got yx instead of xy in the original. Cool, cool. Is that a lot of work? Yeah. There's no two ways about that. That's a really slow fiddly process. So, would you ever use it for something that you can solve in a normal way? Hell no. Okay? I don't want you to use this on... If you have everything is filled out, just do the normal way. It's way faster. But when it's not all filled out, that's a bit more of a problem. So that you know when this happens, have a go at that, just the normal way. See if you can actually get some kind of solution for it. I'll give you 2 minutes to fiddle around with it. It is possible to do the normal way, it's just you have to think very carefully. I mean, not very carefully, carefully.
这3个未知数怎么有2个式子列出来答案？浪费时间问题。简单是往都出解的，除非用代数表。像一葫芦画瓢完事儿。 right? If I do like this one, times 2 together, 2 together minus 4x and plus 2y equals 4, and the second part is plus 2y. Okay, so
Yep.
this one, and this one. So can I say like 2 minus 4 equal and then 4 equal k and 2 equal to m?
If that happens,
Yeah.
so if these two conditions are true, what conclusion does that draw?
That's draw.
What happens if that's true?
No meaning?
For a start, you can solve this for m.
Yeah. So it's m equal 4.
So if m equals 4 and k equals 4, what happens?
M is 4. But no meaning y. Wait. X equal 1 and y is 0.
Not quite. It was a good start. But you haven't quite. You've got one path, and your conclusion to that path isn't quite complete. So you're about 1/6 of the way there. But it's good thinking. It just needs to keep going. Okay. Is anyone at all happy with their progress?
No.
Slightly? Okay. Well, do you want me to give you another 30 seconds or a minute? Or?
Yeah.
Yeah? Alright. It's good to have a play around with these sorts of things just to see what happens. Is anyone just totally lost in the algebra of what they're doing at this point? No? Okay.
So do you mean I just lost the answer?
You haven't lost an answer. Like, everything that you have done is totally valid.
Yeah.
Right? So this is one condition. If 4 equals k and if 4 equals m.
But if it doesn't.
Right, if it doesn't is another set of problem. But even if it does, what does that mean?
It does. Okay. It means.
What I suggest you do, rewrite these with the 4 and 4 instead of k and m, and then you'll probably see straight away what it means.
It's the same.
Which means,
No meaning.
no, it does have meaning. You have two of the same line, right?
Yeah.
So how many does that intersect?
Sex.
Infinitely many, right?
Yeah.
Infinitely. So if this and this, therefore infinite solution,
Yeah. So.
right? But what if they don't equal that?
Um,
You got to keep going. That's a new
Yeah.
item. Yeah. So now you've got 1/3 of the way through.
yeah. What's our?
Yeah. You've got if they both equal 4. What if m doesn't equal 4? What if k doesn't equal 4? What if they don't? What if they both don't equal 4? But that's kind of the subset things. Okay. Cool. Are we done with curiosity or? Yeah.
Wait.
Adam's still intent.
So I need to prove unique solution and if they
You
solution
just
and
need
no
to say when does it have a unique
Yeah,
solution.
yeah.
If it does, what is that unique? It does it ever have infinite? If so, when? Does it ever have no? If so, when?
Yeah, I
是什么东西啊？
forgot. Yeah. Sorry.
Cool. All right. So for a lot of us, this isn't going to be particularly productive. Yeah. Right. We're going around and it's like, oh well, I mean, I can say some things, but it's not every possible case. That's where this matrix stuff comes in handy because you can go through every possible case in a very systematic way. You can go through this the old way in a systematic way, but it'll probably take you longer and you're more likely to stuff it. So, take a guess, what's the first thing we're going to do based on the prior example?
Turn that into a matrix.
Turn it into a matrix. So we get m minus 2, all of that is one entry. A single y, single m, single 2. In this case I've got xy. So that's 2k. Oh, by the way, why was this so fiddly?
Because there's multiple variables.
That had multiple variables.
No, but I mean, as in like there's M, K, X, and Y. There's
So
like,
how many variables here? Two.
Two.
How many here?
4.
Right, how many pieces of information?
uh,
How many equations?
two.
Two. Right? If you have 2 and 2, fine. If you have 2 pieces of information about 4 variables, none. Right? You've got 2 degrees of freedom that they're going to play out, which is no good. So as soon as you don't have at least as much information as you have variables, you're going to have some sort of open expanse to explore potentially. Cool, alright. So we've got this, great. Right, what are we going to do from that based on the prior?
Find the inverse,
By the inverse, okay?
which I hope I did.
Okay, 1 over AD, m minus 2 by 2 minus BC 1 times m. Multiply by D, negative that, and then m minus 2 is what entry. We're all happy with the substitutions? Yeah.
Yes, I think, yes.
Pretty much a copy and paste of argument.
Yes, we could do.
Cool. Get this through. What do we get? 2m minus 4 minus m. This is going to stay.
Yes, it can.
Okay. Oh, we'll simplify this one more time. Yeah, so that's m minus 4.
Yeah.
Happy, happy?
Yeah.
Cool. Alright. Is this different to the prior?
Yes.
Yes. What is a problem?
It has a coefficient.
Right, this coefficient, sorry. Say again.
Like the coefficient of the matrix.
Coefficient in a matrix, yeah, this had a coefficient, hasn't it?
Yeah,
Negative 1.
that was pretty easy to.
Okay, this is purely numerical, yeah?
Yeah.
This one's algebraic.
Yes.
Is there a potential problem lurking in that?
Yes, it's negative 4, you have it, zero.
Negative 4?
No, it's positive 4.
Alright, if m is positive 4,
It comes, yes.
something's going to go haywire. If m equals negative 4, positive 4, what happens?
It equals
You divide by 0.
You divide by 0, so what happens?
nothing. Undefined.
Yeah, problems.
No solution. Sorry, no, not no solution, sorry. Sorry. I'm just going to put exclamation mark for now. Right, something goes wrong, right? Okay, fine. Well, we'll continue as though m does not equal 4. Alright, if m is not equal to 4, then we can keep going. Okay, well, then we get exactly that. Now, I could expand this in, but it'll get really chunky, so I'm going to leave it as 1 coefficient. So, now matrix X is 1 over m minus 4 lots of 2 minus 1 minus m minus 2 close lots of 2k. Leave this 1 over m minus 4 up front. Times all this stuff up. What do we get? 4 minus k. Next we get, where have we got? Over here. Is that right? Yep. Next one is over there, so we get, wait, I should have been getting that. Yeah, that's right. Cool.
Negative 2.
Negative 2m. Yeah. Negative 2 plus k lots of m minus 2k. There we go. Just in the center. Is that good? Right. That's good. 4 minus k, negative 2m plus km minus 2k. Yep, that's right. Okay. Cool. Alright. Now we'll expand it out. So I get, therefore, x equals 4 minus k on m minus 4. Y equals Can we split this up a bit? And we'll split it up like that. Plus minus 2k all over m minus 4. Alright, so we've got some stuff going on. Okay. Well, so yeah, that is a special case, that's the end of the special case, yes, fine. Yes, that's fine, okay, great. Okay, so we seem to have a solution for every kind of M and K. Yeah? Cool, so long as M is not 4. Right? Because regardless of what K is, it's only ever going to affect the numerator, it's not going to create divide 0 problems. So long as M is not 4, you get some solution for X and Y. So the obvious question to ask is, well, what happens when it is 4? Alright?
It works when we do this. What happens if we don't do this?
What do you mean do this? Let's do this.
It works when M is not 4. What happens if it is 4?
Yeah, that's what we were about to do. Okay.
Yeah.
Okay. You could put this into matrix, but it's usually worse if you do that. Whenever you find these interesting cases, it's usually better to just replace all this with this special value that you found. So we'll do it in orange. Yeah, special case orange. So M is 4, so now we get 2x plus y equals 2, and 4x plus 2y equals k. Okay, do we notice anything about that?
Everything on the left of the equal sign.
K equals
Like, go.
Right,
4.
these two things are multiples of each other. The same multiples of each other.
K is 4 and it goes into the solution.
So, I'm going to choose to multiply this one by 2. So equation 1, I'm going to do equation 1 multiplied by 2, so we get 4x plus 2y equals 4. Okay. Okay, so if k equals 4,